All right, everybody. Welcome to Splunking Dark Tools, a Pentesters Guide to Pwnage Visualization. My name is Nathan Bates, and this is Bryce Kunz.
Hey, I'm Bryce. So I run the Adobe's Red Team for their marketing cloud, and previous to that, I was doing more blue stuff at Homeland, and also previously worked in the Department of Defense doing offensive work. So you can remember that I'm part of the red team because I'm wearing the red shirt and drinking the red drink. So.
And I'm Nathan. I'm a defensive security engineer, just primarily working on blue teams. In the picture, I think I might be the guy getting punched. In the room, are there very many red team guys in here? Anybody? So we've got them outnumbered. I don't know. I think we got this. So we work close together. I get to help with some of the red team stuff here and there as new acquisition and different types of stuff outside of our infrastructure stand up. But it's really just a team effort to get a lot of stuff done.
All right. Executives, they got a lot of important decisions to make. They got to decide what latest cyber buzzword they need to acquire. Right? Do they need the IoTs? Do they need the MLs? Do they need the AIs? Do they need the VRs? Do they need the ARs? You know, you gotta get that augmented reality. So, but for reals, right? I mean, part of the natural life of technology is larger technology companies acquiring smaller technology companies. And executives, once they acquire whatever they think is going to boost the overall revenue of the company, then they all celebrate, right? They're like, yay, we did it, we closed the deal, they're not part of it, right? But then that kind of leaves us with us technologies-focused people with other problems.
And when that happens, we have these new acquisitions come in. They've put a lot of time and effort into building up their product. Their entire goal was to add features, add customers, get it built, and get it acquired. When that finally happens, they're not always in the mood to move. They have a lot of attack surface, and the security teams on that new company, they need to look at it, and they need to look at it fast. For us, it's been a challenge because it's something that adds several thousand servers, and we need to know exactly what's going on with them, immediately, which is tough. And those teams, they just don't want to move. Like I said, that was part of their plan, was to get acquired, to get into that place. And sometimes they need a little help coming along. And that's a lot of times what the product, what the dark tools, what we're doing is to help analyze those and help these teams realize that there's a lot of things that they need to fix.
So the acquisition kind of has their roadmap, right? Then they get acquired. They've accumulated a lot of security technical debt, right? But they don't really want to make a lot of change often because they want to get the features on the roadmap out to the customers as soon as possible. So this is really where I feel like a red team can really help out, because they can come in and say, we're going to do an independent assessment of your systems, and we're going to see what is the real world risk that we're currently accepting, right? Can someone breach into the systems from the internet right now? And if they were to breach in from the internet right now, what would be the impact of that? And so really, I think Red Team can help add some objectivity to the overall picture here, with what security controls need to be implemented right now versus what can be mapped out on the roadmap over the next years. But one problem with assessing a new large set of infrastructure quickly is that from a red teaming standpoint, it's very chaotic. Like, I know how to use my tools on my laptop inside my virtual machine, but then the data just stays there inside my virtual machine. And then let's say I need to get this project done quickly. Like I'm told on Monday, I need to know by Friday what this new startup looks like and how egregious it is. Well, then let's say I start pulling in resources. So I pull in Nathan, I pull in other guys from the team to start helping. They all have the VMs on their laptops. And it's kind of hard because every different tool that gets released kind of has its own proprietary format, right? So There's probably been some tools released at this conference, and maybe they did some cool hack, and then maybe they, just outputted their results back to standard out, like the screen. Well, that's fine and dandy, but it really makes it hard to automate processes and to scale.
And it's all about those integrations with any type of size that we have. The bigger things get, the more things that are there. If we can't automate it, it's almost just not possible. It has to be automated, has to be integrated.
So we built dark tools to enable us to do more in less time, to automate a lot of the pen testing legwork that we were doing, and to help visualize the results. So I just wanted to show you guys a quick demo of it so that you could kind of understand at the high level what dark tools is, and then we can dive more and look at how it works under the hood after this. Okay, so dark tools has two components, right? It has a back-end kind of framework that does the scanning and collection and automated pen testing, and then has a front end that kind of visualizes it. So in the back end, we run the console using this run console script. And when we do that, we kind of get dropped into a Metasploit like console here, dark tools console. And then this has like the normal things you would expect, like a help command that will show you all the commands you can list out. And then one important thing about dark tools is kind of the more like associated with my workflow processes, which is you can associate a selector with a project name, and you can associate multiple selectors with the same project. So for example, a selector would be like an email address, an IP, a domain name, those type of things. In these demos here, I'm going to try and keep it pretty simple, right? So we're going to start with a root domain name. In this demo, the root domain is dinoeagle.com, and then the project name is dinoeagle. And then I've built out this workflow called autopilot. This is just basically taking the broad assumption that most of the servers, which you can discover under a new root domain, are going to be in scope for the engagement. I can show you how to customize this a little bit later on in the demo to like blacklist or whitelist certain targets, but we're going to take autopilot the dinoeagle project, which just has that one dinoeagle.com domain. And once you do that, the backend framework starts doing its automated pen testing and starts sending data into Splunk. And then the Splunk Dark Tools app starts visualizing that data. So now we're in Splunk. We can see the Dark Tools app inside of Splunk. We select the project, same project name as what was in the framework. dinoeagle is what we're looking at currently. And then we can see all the IPs it was able to discover, all the subdomains it was able to discover, all the email addresses it was able to discover, all the ports that it found were open associated with any of those IP addresses. And so you can just start pivoting off that data like you normally would inside of Splunk by clicking on it, doing queries, stuff like that. We can also see which microservices are sending in data about this project. Every tool is kind of wrapped into a microservice, and so you can kind of see what microservices is sending in data about which ports. We have like a host reconnaissance dashboard, which shows you all the subdomains and IPs it was able to find. You can also see some type of trending data to see if servers are going up and down at certain times of the day. In the next dashboard, you kind of get more of a geolocation type view. You can see in the lower right that you can see the servers are located in Europe, like Ireland. That's that kind of yellow box over there. So in a real world assessment, I was assessing a solution, and everything was clustered in the US and Europe, except for there's one little dot in China. So for me, that kind of like highlights there's one server out there in China. We should go check out, why did someone set that up? What is that? Look kind of non-standard. That's really what this is trying to help you do, is automate a lot of that pen testing legwork to help enable you to spend more time looking at the things that are anomalous or egregious. Get traceroute data in there. That's pretty normal. Does UDP checking. And then, first it checks for whatever TCP. It tries to check using multiple methods for open TCP ports to the internet. And it finds a TCP port that's open. It uses kind of some other logic that I wrote to determine what that service is that's running on that port. So you You can see here that port 8080 is open, but it's actually determined that SSH is listed on port 8080. So, you know, even if people are trying to do slightly tricky things like change the SSH port, that's going to be pretty obvious in this dashboard here. Okay, so it tries to automatically discover unlinked files too. That's just a wrapper microservice that wraps around the GoBuster open source tool, and then parses back out the data and sends it in Splunk in the right format. You can see here that we found some SSH keys that are inside a hidden directory on the web server. So someone's made an operational error there. And then we saw in the previous screen that SSH was running on port 8080, a non-standard port.
I think it can definitely just be noted that a lot of these, the dashboards were designed around a lot of targets. So like with these smaller examples, the data comes out and you can still extract what we're looking for, especially for this use case. But really, it definitely shines with a lot of hosts in there.
Yeah, and with that regard, over here on the left, we came up with this weighted system that tries to rank all the hosts. So imagine if there's thousands of servers, it would put the one that it thinks is the one you should look at first at the top. And you can tweak that weighted system if you go inside the Splunk app and kind of change how that works under the hood. Okay, so combining the information that we've collected from these dashboards, which are available inside the Darktools Splunk app, we can now start actually doing the pen test, right? Up until this point, that was pretty automated. We can browse over to the dinoeagle.com server. When we go there, we can browse into that unlinked SSH folder, which had the SSH private key in it. And we can download the private key. And remembering back from that second dashboard, it showed us that SSH was listed on port 8080. So now we can try this key that we downloaded on port 8080 using, yeah, the username that was inside that file. We discovered the username using the email discovery function. And when we do that, we're able to gain access to the target. So that's a little bit of a contrived example, but I actually pulled that from a bug bounty report. So that was a real scenario that a researcher reported for a company. And Darktools is just helping automate kind of that process of discovering those.
All right, so that gave just a quick example of generally what's happening, the type of dashboard, and what you can walk through. But it really is just about what you can do with it. If you can't action the data, even from normal pen test reports, then it's not worth a whole lot. You can give it to teams, they may look at it, and not ever do anything with it. It really is pulling everything together. So through this automated framework where it's doing all of the scanning, it does normalization, it dumps everything over, it puts it into a location where with all of your other thousands of hosts, that edge case scenarios, they rise to the surface pretty quick. And it's really through just that big data with the visualizations to understand what's missing. Things like the SSH key sitting on a web server. I mean, that's a funny example, but it honestly is something that pops up. And it's small items like that a lot of times make it the easiest to pivot through environments. So when that data is there, the visualization's there, people can analyze that data. Both the red team members are primarily who are using it right now, but because it's in a location that's in the same place that your blue team data is, your defensive, normal security logs, network logs, like IDS, everything else, you can do a lot of purple teaming or red team, blue team type collaborations with that data because you have the attack data and you have the defense data in one place. That allows a lot of quick remediations and actions because it's easy to tie together exactly what you attacked with and what visibility you should have, or if it wasn't there, what you need to fix. And it definitely, like I was saying, it goes back to the collaboration. If you can get that to come together in one location. You can use the data to keep moving and actually get things done. The more people that are looking at it, the more you're going to be able to find those small problems and keep moving through that. Is anybody, are people using Splunk in the room? Anybody? All right, so there's a few out there. What's great is with all of the dashboards and how we're sending through everything right now, it's standard Splunk. So you can break everything down and go through and look at how we're doing it, understand what needs to be changed to be able to work with your environment, and then be able to make sure that everything's fitting. Through the visualizations that are there, it's the outliers do rise to the top. And in our experience with what we've done so far, it really is definitely those outliers that usually lead to the remote code execution. The weighted charts that Bryce went through, it's based off of weighting of the assets, based off of kind of what's available through ports with some of the other scan datas. And that definitely, it's been dragging that information to the top on these visualizations.
Okay, so I just want to talk for a minute about how Dark Tools is working under the hood. So kind of give you the overview. This is kind of how the backend is designed. So as you saw in the demo, the red teamer or operator starts up the console. That console, really what that's doing is just connecting out and hooking into a message queuing system. And then that message queuing system has these microservices that are running on it. And then the first set of microservices are kind of all around reconnaissance. So you just talking specifically about the autopilot workflow, which is kind of the simplest and kind of the most useful use case. The first thing that happens is when a selector hits the message queue, it gets passed over to a microservice that finds subdomains. This mostly is wrapping around GoBuster, but there is some additional logic in there if you look at my Python code. Then once subdomains are found, that passes all the subdomains over to another microservice that discovers what IPs those are. And then it kind of builds this like JSON blob of targeting data. And then once we have the IP address, another microservice determines whether this IP is on a black, white, or gray list. Blacklist being like DoD IP addresses we should never talk to, or null routed IP addresses on the internet you should never talk to, it just doesn't make sense. Whitelisting IPs, that'd be like when you scope out the engagement with the customer, you would add in all the IPs and net blocks to that list, and that would automatically mark those selectors as white. And then gray is kind of a concept where when you're talking with the customer is like, I don't really know what my IPs are, but all their stuff's in AWS. So you could add like AWS's net blocks to the gray list, and then it'll mark the selector as gray. And then subsequent microservices can take different actions based off of how a selector is marked. So if it's on the blacklist, microservices won't do anything. If it's on the whitelist, they'll do fold checks. If it's on the gray list, they might just do some non-intrusive type checks. So that's the general concept there. All microservices, when they finish, send data to Splunk in real time via Splunk's HTTP event collector that Nathan will talk about more in a minute. So you don't have to wait for everything to finish. As each little microservice finishes their job on each selector, you'll get that data updated in real time in Splunk.
Is anybody in the room using the HTTP event collector? Anybody? Dwayne? There's a few others. Oh, those guys should be. So we're big fans of it with Adobe. We use it in a lot of our projects. Krister was up here before us talking about Hubble, and that primarily delivers everything through HTTP event collector too. This is a Splunk-specific technology where you just enable the services on the heavy forwarders is how we're doing it. You enable the HTTP event collectors. You generate a specific token that's assigned to an index. When that message is created, it's a JSON blob object that's posted, hits the HTTP event collector. It's received. It looks at that, confirms the actual token, and then it assigns and puts everything into the index from there. It's pretty standard. It's not too complicated at all. There are a few open source solutions that are similar that work with Elk, but if you're using Splunk and you're developing any type of project like this, it's awesome. So this is an example of what are the type of messages that we're delivering from the framework is. So there's an authorization header in this statement. It says Splunk has the actual token, is this the long number that's there? It goes out to the location of where it's collecting, and then it's just the JSON blob that's in key value pairs that's broken out. The project, domain IP, protocol, port, all of this is automatically extracted and brought into the application, into Splunk.
Okay, so as that data gets sent into Splunk in real time by the HTTP event collector, the DarkTools app is visualizing that as it's coming in. Okay, so the next thing is more microservices. The next microservice tries multiple techniques to discover what ports are open on the internet, and then if any of those come back as open, another microservice tries a couple different techniques to determine what the actual service is that's listening there. And then once you get this targeting blob together, that gets sent off to Smokey, which is our dispatcher, and Smokey sends out to many more microservices, which are called the Bandits. So, you know, one of those microservices finds web resources that are unlinked web content. Another does like UDP scanning. Another does like OSINT, like does whois IP checks. Another like tries creds if the service is SSH, regardless of what port it's on. So you can basically write as many bandits as you want. They all kind of accept that same targeting data, and then they take some action and send the result into Splunk afterwards. So, okay, great.
So it goes back to why Splunk. There's a lot of different options with this, and really, I think that if we were to keep working on the project, we'd make it work with other systems too. We are big Splunk fans, though. It works well. It can scale very, very large, and it's simple to get going. So for our system, where we are testing with maybe a couple thousand systems, we were able to put it on the free instances and use the free license, and it wasn't a big deal. But when we finally scaled that into production, it fit directly in with the rest of our data, and obviously Splunk can go, you know, almost as big as you want. It can go very, very big. A big part of that also is enterprise security sits on top of Splunk. That's their SIM, and all of the blue team data, the defensive data, it's all sitting there already. It has their correlation systems already built in for extracting the data. It has all the risk framework built in, and a lot of this can be applied directly to that. So the setup is very, very straightforward as far as getting everything running within DarkTools. The framework from the Python framework, there's the run console command. I think Bryce may have actually showed that initially for the initial setup. It breaks everything out. Docker is required to be on that system. But it's very, very straightforward. The Splunk install is, I mean, it's normally RPMs. You accept the actual licenses, move everything through. Index creations, it have to be done. The HTTP event collector tokens are there, and then the apps. We thought about doing videos on this, but honestly, most of this is very, very straightforward. And yeah, let us know if you have any questions.
Okay, so Bandits, it's designed so you can build as many as you can imagine. Like, for example, let's say a new vulnerability comes out, like options bleed comes out, or what's the latest one? Tomcat, right? Tomcat's got the put vulnerability that just came out. So let's say that comes out and you want to quickly check all your infrastructure. You could wrap the researcher's proof of concept code inside of a Bandit microservice, and then that would automatically go and check your servers and then send the data into Splunk. And then development of a Bandit is pretty straightforward. Basically, you have a function that does work, right? You do work, and then which is accepting in kind of that JSON targeting blob. And then you have another then your process it either through your own custom, like you do your check either through your own custom Python code or through using some third-party tool that's wrapped into the microservice. And then you normalize the output of that tool into a JSON, and then you use the Splunk event function, which is a function, like a shared library that I wrote, to send that data automatically into Splunk via the HTTP event collector. So there's quite a few examples already in there of like capturing screen output and then sending that into Splunk, like having a tool run that writes to a file and then parsing that output and sending that into Splunk. So if you have a use case, chances are there's a module in there that does something very similar now that you can copy paste.
So when the data is there, it gets delivered into Splunk. You want to be able to use it. You want to be able to make it complete as possible, as easy as possible. So there's a few places that you can do that. If you work on your data beforehand, if you use JSON, if you do a lot of that can be broken out already or done within Python. So that's the reason we went with JSON. That's the reason we went with the HTTP event collector. A lot of that is just to keep it as clean as possible. Within Splunk, there's per source types. We've broken out some of the cleanup where it wasn't possible just because of the source types, if they had to be integrated or anything like that. And that can be just done with normal regex. It's just field extraction where everything's kind of applied and broken out. Some of the lookups we're creating are just to tie some of the separate source types together to use different types of the attack tools, as far as some of them are IP based only and don't have domains, and some of them have the domains with domains that it's broken out. And a lot of that data just works together when it's all when it's together. So that's there. The GeoIP is pretty standard. We're updating more frequent than Splunk or ES normally do through some other requirements that are added on, but a lot of it's pretty straightforward.
So I just wanted to talk for a minute about how you could get up and running with dark tools if you wanted to. So first, the code is on GitHub, so you can pull that code down. The Splunk app is on GitHub, so you can pull that down if you want. And then there's a standalone script, and what this is going to do, it's going to run all the microservices inside of, and basically inside a single, on your laptop or inside a single VM. Really the only requirement here is that you need to have Docker on that, because all the microservices are Docker containers that run. So this would be like an example of like, I want to install Splunk on my laptop locally, and I want to run all the microservices on my laptop locally. I want to take that to a network that doesn't connect to the internet or do development on it. That would be a good use case for this. But in reality, that's not, I mean, if you're just going to have it on your local laptop, that kind of defeats the purpose of dark tools, right? Unless you're doing development. So the whole point of dark tools is scalability, right? We're trying to automate a lot of the pen testing tasks. We're trying to scale those. So in reality, this is the way that I have it deployed. Each tester will run the console on their laptop using just using that run console script, which is only dependency there is Docker. That's going to connect to a server that is running the message queuing microservice. And then that's going to connect out to other servers that are running more microservices. And this can be redundant. So let's say your discovery of web content against targets is taking a very long time. If you just create more of those microservices on more servers, that will automatically scale the task out to those microservices. So it takes care of all that as part of the framework. So scaling is not automatic yet. Hopefully in some future version it will be. But yeah, right now, when you generate from the framework, it just makes these scripts, and then you just run the scripts on the servers. As long as they have Docker, then everything works. So that's kind of the way I do it. So basically, I have, how many servers do I have now? Like I run this daily. It just continually runs on about 10 servers, right? So, and then those are checking thousands of servers and then sending that data into Splunk. Okay, so I wanted to show you a demo of something a little bit bigger. It's not as big as I do in production, but hopefully it starts to give you guys more of the concept of why this is useful. So
The production day is awesome, but we realized it's probably not going to be something we can show on stage, right? Which is kind of sad because that's what everything was developed around, but.
okay, so we're going to run console again, just using that script. Remember, the only dependency here is really that we have Docker on the Pentesters laptop. That's going to drop us into a Metasploit-like console. You can type help here if you want to see all the commands. You can edit that white, black, gray list from here if you want. You can add more selectors to projects if you want, all that. So from there, we're just going to list out the projects, and then we're going to start targeting the second project, which is called Dark Grifter. There's only one selector associated with Dark Grifter right now, and that's darkgrifter.com. So basically, it's going to try and discover all the subdomains underneath Dark Grifter, and then start trying to do automated pen testing against those, as long as those IPs are on the whitelist. So here we go. We autopilot the Dark Grifter project. You can give your project super cool code names, as if you are a spy, but that's part of the experience, right? Okay, Dark Grifter. So once that runs, that just sends the request off to the message queue, and then you don't have to worry about the console anymore. So when we come over into the app that's inside of Splunk, now we're getting the data as it comes in real time by the HB event collector. We can see that it's found about 10 IP addresses associated with about 12 subdomains. It wasn't able to find any email addresses via OSINT, by like Google searching types for that subdomain, for that root domain. But it was able to find an array of ports. It's probably hard for you guys to see, but one of those is like a MongoDB on the internet. That type of stuff, would immediately stand out as something that would be a finding, needs to be remediated. Because typically MongoDB doesn't have like authentication on it, right? So. All right, so if you click on anything, you dive into the event, that's just a typical Splunk workflow. So you can correlate on it. If you have other blue team data coming into Splunk, they can start leveraging this data too. So multiple dashboards, same dashboards as before, but now more targets. More data is getting sent in from more microservices, trying to help you visualize what microservices are sending data about which TCP port, just so you can understand where maybe you're having bottlenecks in the framework. We can also get a count per domain. So, a lot of times you'll find domains that have, multi-hosting, right? So multiple subdomains all point to the same physical server. That server has one IP, and then Apache is using like virtual hosts or something like that. And you can see over here on the right, we're trying to visualize that mapping for you to help you. Because maybe one of those subdomains is not important, but maybe another one is super important. And so if one's insecure and we exploit under that box, maybe we can move over and get the data for the domain, for the web app we actually care about. We're also doing SNMP checks. That's one of those bandits that's out there. We're checking for SNMP that's accessible via the internet. Probably shouldn't have SNMP exposed to the internet, even if you've changed the community strings. So it's a general rule of thumb. Checks for other UDP services, all that. Okay, so here we're mapping the ports to the services again, right? So non-standard ports, as far as I tell, the Dark Tools doesn't get tricked by that. I've tested it pretty extensively. And then also trying to map, which ports are open on which servers over here. So just trying to help automate some of that legwork associated with finding the most egregious servers. Okay, so we're doing the content discovery tab now. We can see that it was able to find some unlinked content on the server. Specifically on the jira.darkgrifter.com, it was able to find a /logs directory. Then over here, you can kind of see on the left side that weighted risk system. I know it's a little bit blurry in the video, but it's jira.darkgrifter.com. That's the top one. which is also that one that has that logs directory. It's saying, hey, we should start with that. It has the most things available. Like we found a bunch of egregious stuff associated with this. We're showing you all the servers that have HTTP open, all the servers that have SSH open, in case you want to do some type of other attack against just those ones that are similar in nature. Weighted risk system, that's what we're talking about. It wants us to go look at the Jira box more. So we browse over to jira.darkgrifter.com. It's running some weird web app that's not Jira, right? So probably a good sign this box is not well managed, right? Does anybody know what this app is, by the way? Okay, this app, this is a sidetrack, but we're gonna go down it. It's called CyberChef, right? So any of you that do CTFs, or if you do defense, you should definitely check out CyberChef. It's an open source project which makes decoding obfuscated strings like very smooth. You basically like layer cake. So if you see the first layer is base 64, you drop decode base 64. If you see the next layer is hex, then you drop decode hex. And then it'll automatically run through all that and output it here. So anyways, if you do CTFs or stuff like that, CyberChef is pretty slick. Or if you're trying to deobfuscate any type of code. It's open source and free. So we decide, there's that logs directory, right? Let's go check that out. All right, so what is this? The web server looks like it's mapping over to var log, right? Someone's put like a symlink in the web server on accident. It's now letting us read the files that are in var log, right? So that's all, that'd be like a finding on a pen testing report, right? But what we really want to do is we want to show impact. So we want to go farther, right? We want to get code execution on this box. So how can we take access to var log and turn that into a remote code execution on the box? So I just want to show you a super simple trick that unfortunately works more often than it should. So if you just mine through auth.log, what does auth.log record? It records authentication specifically via PAM, and SSH uses the PAM subsystem. So SSH authentication. I mean, don't raise your hand, but how many of you have seen someone make a mistake when they're trying to log into a box, right? So look at this.
I've never done it. I'm just...
The user, someone tried to log in with the user of super secret do not tell my mom, right? Does that really look like a username? Like, no. And that looks more like a password to me. But then we don't really know what the username is associated with this. Oh wait, what's the next thing the user does? Once they type their password in the username field, they realize they have a failed login, they do it the correct way next. So then we just scroll down and see who's the next valid user to log in. And then we can see new session was successfully created for Brian, right? So we can pretty much correlate this to assume that that's probably Brian's password. He probably screwed up and put it in the username field and then logged in. So we give this a try to SSH into the box. So we're going to SSH in as Brian to the Dark Grifter box, jira.darkgrifter.com. And we're going to leverage that password that was inputted at some time in the past as part of the username field. And then that's going to get us SSH in the box. So now we got remote code execution going. So I know these are pretty contrived, simple examples, but really, I find it really interesting to go read the bug bounty reports, right? Because you'd be surprised how similar this is to what's in the bug bounty reports for public companies. So a lot of times it's these simple things that gives the attacker just a little foothold in your network. Once they have that foothold, they can blow it up, right? So expand access after that.
All right. So this is definitely, super alpha version 0.001. But it is working for what we want it to do. In future versions, the more we're working on it, obviously more modules with checks. Bryce talked about options bleed. He talked about the latest Tomcat vulnerabilities. As far as things that we'd want to check and add in the future, it's always happening. I mean, we're all in security. We're all watching these things happen, and there's a lot to move forward on with that. Within enterprise security, they use data models heavy for a lot of the correlation searches, and trying to fit attack data into current data models wasn't something I could make fit. I don't know. It felt like, sticking a circle in a square. It just wasn't, it was not the same type of data. So trying to create a standardized attack data model is something we want to get done. It's something I think we'll need to work with other people and work with Splunk on, because we're not the only attack data. There's a lot of attack data out there, and I think it'll be becoming more and more common to put that in Splunk. Correlations within Splunk, we talked about ES and the notables. It's just taking both the attack data and the defensive data together and being able to confirm what's happening, making sure you have the coverage and locations, and make it so you can action that data. The trending in Splunk, it's the more data we have over time-based attacks, kind of like with what we're doing, the more we'll be able to do with both machine learning, MLTK, and with any type of other trending in Splunk. It was something that we did look at initially, and there's a lot of room to grow on that, and I think it's something while we get more and more data, and then it's something I think we'll be able to pull a lot out of. Within our systems, if we don't have APIs to control, to add objects, to add new domains and IPs, a lot of things like that, it just they don't move as fast as they used to, and it doesn't get maintained. So adding the API for further integrations will be big. And then Bryce actually mentioned it a little bit earlier, or talking specifically about being able to auto-scale based off of the usage of the Docker containers is something I think we want to work towards too also. But that's what we want to keep moving forward to. Like, it's doing well now. We get great data out of it, but there's definitely a lot of room for growth.
So if you have questions about it, I'm Bryce Kunz. I'm Tweak Fox on Twitter. Feel free to message me. Happy to help. And Nathan is Brutus on Twitter. So feel free. Nathan's kind of the Splunk expert. I'm kind of more the framework developer. So that's kind of it. The code is up on github.com/darktools. So I try to make that easy to find, but apparently it's not always. So, yeah, we appreciate you guys coming out.
Definitely.
Coming out today. If you have questions, happy to have questions. So.
We'll be here the rest of the con too. So yeah, if you find us any other time, let us know if we can help with anything. Thanks.